All right, well, thank you very much for that glowing introduction. Yeah, so I'll just kind of quickly highlight, some of the specifics. So as mentioned, I work for Crunchy Data, but I'm really here to talk with all of you about Postgres, right, and about where Postgres is going and what we're doing. Kind of some of my specific backstory, as mentioned, I'm a committer. Committer is one of the people who actually reviews code and commits it directly into the Postgres main repository, main Git repository, something we call Git master. I'm also considered a major contributor, which is basically means I've been with the project for a while and I've hacked on some pretty big features. One of the big ones that I worked on was row-level security in Postgres 9.5. In fact, I'll actually be talking about that a little bit tomorrow morning since we had a change in the schedule. I also worked on column level privileges, which gives you the ability to grant things down at an individual column level. And then I implemented the role system, and it turns out I have a bug in my slides, which somebody else pointed out to me, and I keep copying these slides over and over, and I keep forgetting to fix it. I implemented the role system in 8.1, not 8.3. How many people here have been using Postgres since 8? Okay. How about older? 7? 7? Wow. Awesome. Who remembers the old user group system that we had in 7? So back in 7.4 and 7.3, we had users and groups like we had in Unix. And then I changed all of that in 8.1 to be the role-based system that we use today. I've also hacked on PL, PGSQL, PostGIS. I have code in the Linux kernel. I have code in SendMail, a few other things. So let's talk about the upcoming features that are going to be in Postgres in version 12. So I'm going to kind of go over features here. I kind of broken them down into discussions about pluggable storage, partitioning, and then performance. And then I go over some of the SQL features and then some of the kind of more systems administration type of nice new features that we have. Not all of these are guaranteed to be included in version 12. Just to be clear, where we are currently in the overall process for those who might not be familiar is that we have an annual release cycle where every year we release Postgres major versions in around the September-October timeframe. And what that means is that we do development through until about April 1st. So what will happen is that we're in March right now. So we are currently in the last of the what we call commit fests. These are the last of the sprints, if you will, that Postgres uses to do development work inside of. We're in the last one now. It ends on April 1st, and that's the date we have what's called feature freeze. So right now, there are still new features going into Postgres. Right? Even as we talk, some of the things I'm talking about here are not actually even committed yet, but they've been under discussion, right? And they look like, at least from my perspective, they look likely to be committed. And so that's why I've included them here. As I'm going through this, please ask questions. I love having questions from the audience. I love having a dialogue. So as I go, please feel free to shout any questions you have. Or if there's anything particular you're interested in, I'd love to chat about it. So once we hit April 1st, that's when we'll actually have our feature freeze. Now, even after April 1st and we have our feature freeze, there's a period of testing that goes on from that point forward, and some things can end up getting reverted, right? So even things that I talk about here that have been committed might end up being reverted, right? Might be taken out because for whatever reason they just weren't ready. And that happens sometimes. So just something to be aware of as we go through. So the first really big one here is pluggable storage. So there's been an awful lot of work and effort and discussion going around what's called pluggable storage in Postgres. Postgres today has really one storage engine, right, that it's built with. It's got a heap and it's got just one kind of heap, right? We have lots of different index types, but ultimately our storage comes back to we have one primary heap, and then like all of our indexes are secondary indexes, which means that they refer directly into pointers on disk. And so a lot of that's getting changed, right? And the reason is that our existing heap structure is very row-based, right? Where every row has a header associated with it, right? And that header is pretty big, right? And that's one of the downsides that we have in storing very narrow tables, right? A narrow table being one that only has like a column or two included in it. And that's a difficulty for Postgres, because what happens is that tuple header, it's about 24 bytes, right, ends up being larger than the actual data we're storing on disk, right? The data that the users asked us to store. And why is that? Why is that? It's because of the fact that we need to track visibility information and whatnot in that header information. So, but there's a reason why people have what are called columnar storage, for example, right? Sometimes it's very handy to be able to have a single column of data represented inside of a file, because you can process it much, much faster, and in fact it compresses much better as well. So this is where Postgres is headed, is the ability to have multiple different storage formats underneath. And that's what pluggable storage is all about. So this is going to be the basis for columnar storage coming up, probably in v13 or maybe 14, depending. And it's also going to be the basis for what's called zheap or zheap, depending on if you're in the UK or not. So zheap is a alternative heap that is going to allow in-place updates, right, and uses an undo log instead of using just the redo log that Postgres has. So in the future, you may find that Postgres has both undo logs and redo logs, right, and it has both the regular heap and zheap, and possibly columnar storage options as well for storing, things like particularly analytical data that's very, very good to store in a kind of linear structure on an individual column basis. So Postgres is really moving forward a lot in our ability to have a lot of different options and be able to address a lot of different use cases. Specifically for version 12, we really are just at the kind of building in this infrastructure for pluggable storage. We won't actually have anything user-facing in terms of pluggable storage in v12, or at least I don't think we will, right? It's not going to be until v13 and later that we'll actually have new storage mechanisms that are built on top of this pluggable storage feature. Any questions about that? I like hearing questions, so think about questions if you have them. All right, there's also a lot of work that we're doing around partitioning. So when you have a large data set, a large volume of data going up towards the potentially terabyte range, right, is where I would probably start to think about partitioning. You want to be able to break that data up to be able to manage it more effectively. And the way you do that is through partitioning. And Postgres is adding in a whole bunch of new features to make working with partitions in Postgres easier to deal with. In particular, this is all based on what's called declarative partitioning in Postgres. So how many people here remember the old inheritance partitioning scheme, right? Lots of people. So in older versions of Postgres, you could only use what was called inheritance, right, to do your partitioning. And that unfortunately didn't work very well because it didn't scale out to thousands and thousands of partitions. And that was a difficulty. So instead, we moved away from the inheritance base, which was extremely flexible, right? It gave you a lot of flexibility to do a lot of really neat and interesting things, but it didn't scale very well. And we've moved now over to having declarative partitioning. So now that we have declarative partitioning, we've had that for a couple of releases now, and now we're starting to see the real benefits from that in terms of building on top of that declarative partitioning capability, more and more features to make working with partitions more effective and easier to deal with. So a few things here I'll mention. Attach and detach concurrently. So this is the ability to kind of on the fly attach a partition and detach a partition without having to take very heavy locks, right? Why is this important? Because you want to be able to add new partitions to your partitioning scheme without having to take any kind of outage or downtime or have any impact on the ongoing operations of the system. So that's something that's a really big deal. Much faster planning when there's a lot of partitions involved. So this is another one of those features that I'm really hoping actually does land in 12. There's been a lot of work going on, but the old inheritance-based planning system was very flexible, but it also meant that planning was very slow when you got over a few hundred partitions, right? That was one of the big difficulties. With declarative partitioning, the initial declarative partitioning patch didn't actually change that. It still used the same inheritance planner for doing the actual planning. We're now working to fix that, right? We're now working to actually implement a much faster planning methodology for dealing with partitions. And we can do that because declarative partitioning constrains the overall space more, right? With inheritance, you couldn't really do anything to improve the planning because of all the different comparisons you had to make to ensure that you got the right partitions, right? That you only eliminated partitions that you knew couldn't be part of the actual result set. With declarative partitioning, because you have very clearly defined ranges or lists or hash partitions, right? It's very clear you can make those determinations much faster about what partitions are actually going to participate and what partitions are not going to participate for a given query. So that planning work is now going on, and hopefully will land in 12 to give us much faster planning with a lot of different partitions. And of course, that's going to increase the number of partitions that can be reasonably used. Yes? So there isn't yet one that's built into Postgres. There is a really useful tool though called pgPartman, which will automate all of that for you. And it's been updated to work with 11 and will be updated to work with 12, right? So pgPartman would be what I would recommend if you're looking for a tool to automate the adding and removing of partitions over time.
But if I understand correctly, pgPartman, what it does is it would add incrementally based on time.
There are some different options for it, yes.
But it would not, like, let's say if I'm trying to insert data, which is, let's say, 1st January 2019. If I'm trying to insert that data today, and there is no such partition that exists right now, it would not automatically add that. Like,
No, there's actually, so you can set up triggers and whatnot, but it's not a good idea, in my opinion, to do.
Triggers would not allow that. I tried that recently. So triggers would not allow that because I cannot add a partition while there is a lock on the
Yes, so the locking that we're doing to reduce, so one of the things that we're working on reducing here is the locking involved there, so that we could potentially allow a trigger to do that.
Okay.
But I still am not sold on the idea, frankly. There's downsides to that in my experience, but I think the new locking would actually let you do it.
Okay.
So that one, like, we submit for data, we get some foreign fields, right? So we don't know what a field contains, so we can get it.
So yeah, if you don't know what's coming, then that can be a problem. Yeah, I don't know that we really have a great solution for that yet, but certainly pgPartman is what I would recommend if you have something that's like time-based, right? And that works really, really well. If you know all the partitions you're going to need, you just need to have something automate the creation and adding of them over time. That's where I would use pgPartman. But I think, you know, now that we're going through, I don't think I specifically mentioned it here, but there's been a lot of work reducing the lock levels that are required to do the attaching and detaching of partitions. And so I think we're getting to a point where you'll be able to do trigger-based. I still don't know that I would necessarily encourage it though, right? Because whatever process is about to go, has to go create that partition, right? It's got to go do a bunch of DDL and whatnot, which is not, I don't consider that to be ideal. I would rather actually create them ahead of time, right, a priori with whatever process I can. But I realize that may not be practical in all cases, which is why we have in Postgres the ability to have a default partition. So we do have that already, right? That I think went into 11 if I remember correctly. So we have the ability to have a default partition, and then you can suck data out of the default partition and put it into some other partition if you want. So that's another way of approaching that. Yes, you would have to go through that in order to add another partition, because otherwise we don't know what's in it versus what's not. Well, the ability to attach and detach concurrently, right, means that will hopefully be less of an issue, but I don't know that there's something that would solve that further than that. Not yet, right? I mean, I get the point, right? You can't add a default partition. You can't add another partition when you have a default partition, right? Because at least if you're adding a new range.
It's like keeping your data, it's not discarding your data. If you have default partition and it's not falling in the range of the partition table, you can
Right.
still insert the data in the table.
Yep.
It should be the default one. But at some point, if you want to have
If you want to,
proper
if you
partition,
you have to split it out.
partition,
Yeah.
move the data across, and then you have to clean up that default partition so that the future,
Right. If the default partition has only the data you know needs to go into the other partition,
Yeah, so if you have
you
not
could
defined any-
potentially avoid the actual movement,
if you
but
have not defined any bounds for any of your data, so in version 10, after you discard your data, it will say, okay, there's no range, there's no partition for this data.
Right.
This data you're trying to insert is defined, but in 11, it will actually accept your data. And
Yes.
retain in the default partition.
right, right,
And then you can create a relevant partition.
right, and then you can create it, yeah, exactly.
In case a new partition is created and the data for that partition is already in default, once we create a new partition, the data will move from default to the new partition.
No, that's what we were just discussing. It won't happen automatically for you.
So you have to do it
You have to do it yourself, right? Now, if you happen to know that the data in the default partition matches what you want the partition to become, right, then there's a little bit of hokey you can do to detach it and then reattach it with the constraints on it that you want and then add a new default partition, right? But it still ends up taking out some pretty heavy locks, right, which is the downside.
And one more question is, do we have the concept of global index and local index?
So Postgres, so that's an interesting question about Postgres. So, and unfortunately, I don't think there was very much in 12 done around this. But what we got in 11 was the ability to have indexes where the index includes the partition key can be defined at the partition table level, right? Now Postgres, even before that, supported the ability to have indexes on individual partitions. And you can create an index on an individual partition of whatever you want, right? But the downside, the thing we don't have right now is what you're talking about, which is global indexes, right? So we do not yet have an index that can span multiple partitions where the partition key is not included, right? Right now, if the partition key is included, then we can have one index. It's not actually one on-disk index, right? But it's one index defined at that parent table level, which then also would allow things like foreign key relationships, right? But those have to include the partition key, which I realize is not always what you want, right? Because sometimes you'd like to have a unique index that covers multiple tables, multiple partitions, that doesn't include the partition key, and today we don't have that. So that would be something that would be very interesting for someone to work on. I don't know of anybody currently working on it, but that would be an interesting thing to work on. So another thing that we did in 12 that actually that's in already is this ability to do multi-insert during copy statements. So if you're familiar with copy, right, that's the way you bulk load data into Postgres. Well, it used to be that with copy going into a partition table, we actually did individual inserts into that table. And the reason for that was because we weren't sure what partition it was going to, and we had to do tuple routing, right? There's been a subsequent improvement to make it so that we can actually do this kind of batch inserting using, when copy is being used with a partition table. And that means it's much faster to copy large sets of data into partition tables in v12 now. So that was an area that needed some improvement and has gotten it, which is great. We also have this new PG partition tree function, which is pretty handy to actually display the partitioned table, right? So you can query this and give it a parent table, and it'll give you this very nice tree or very nice list of what tables are where in the partition hierarchy, because Postgres does support multi-level partitioning, right? You can have multiple levels of partitioning, so this is a really handy thing. And I honestly think that there's probably more things in here that are interesting that I haven't even included in this list, right? There's been a lot of effort going into improving partitioning in Postgres for 12, and I think that's going to continue to happen. Yeah?
How does in the back the directory structure of the file get created when we create a partition table in Postgres?
How does the file get created?
Yeah, because generally we have one file for the table, right?
Yes.
An index file.
Well, yeah, you have a file for the table, for the heap, and then another file for the index, yeah.
So in partitioning, how does it?
So in partitioning in Postgres, each individual partition looks exactly like a regular table. In fact, the attach detach, all it's really doing is updating things inside of the catalog, right? We don't actually modify the tables on disk at all.
If you have one file with OID, it's still the one OID.
But it's not the OID, it's the rel file node, which is not the same as the OID. But it's the rel file node, yes.
It's still the one rel file.
Yes.
not multiple.
Well, Postgres always, I mean, so every table in Postgres, like it starts out with the file, with the rel file node, right? And then that file can get extended, right, by having multiple dot, dot 1, dot 2, dot 3, yeah. But it's the same way. Individual partitions inside of Postgres each get their own rel file node, and each are extended in the same way.
Each partition have a different rel.
Each partition will have a different rel file node. That's correct. Yep. That's how it, I mean, because partitioning in Postgres, again, is the individual partitions look exactly like a table, right? And you can flip back and forth between them being an independent table and being part of a partition hierarchy. All right, parallel query. So parallel query is something that Postgres has actually had for a while, right? We actually got parallel query in 9.6, but it didn't work with the serializable isolation level. Serializable is actually the highest level of isolation that you can have inside of Postgres, and it was a little bit unfortunate that you couldn't do parallel query with it. The reason for this is that it's actually somewhat complicated to make sure that you're tracking all of the potential reads and writes that could be involved inside of a serializable, inside of a system where serializable isolation level is being used. So what we are going to hopefully have, in fact I was talking to Thomas about this at FOSDEM, is the ability to have parallel query with serializable, right? And actually be able to have that highest level of isolation and be able to have parallel query for it. And what that'll do is that'll give us more places where you can have parallel query being used inside of your applications. And it means that application authors will have to worry less about concurrency issues because serializable in Postgres really provides that true serializability. It means that you can not have to worry about concurrent reads and concurrent writes, right? Postgres will figure out whether or not what you're doing is actually dangerous or not and report it back to you when you go to commit it. And now we'll have that hopefully for parallel query. By default, Postgres in version 10 did have parallel query enabled. And once this goes in, it'll automatically be enabled for serializable transactions as well. That said, I would say that you probably want to be thinking about tuning those options, right? If you really care about parallel query, you might want to look at tuning them because the defaults are pretty, they're meant to have a minimal impact, right? We don't want to end up in cases where like suddenly every query is being parallelized and the system is ending up being less efficient overall because of it.
How does we increase or decrease the number of workers processed like that?
There's options for increasing the number of worker jobs that will be considered for a given query, right? So you can set max parallel per gather, and that'll say how many workers are going to be allowed to be considered for a given gather node, right? So it's all. Oh, what's the default offhand? Was it 4? 2? I forget exactly. Is it 2 per gather? It might be. I forget what the exact default is, but I would consider moving it. Do you know, Andre? Is it 2? It's 2. Exactly. Like I said, we kept it really small to avoid any impact. Anyway, do you have a question? So that is also something that's being worked on. We don't have it today, but I know that there was I think Thomas Monroe was also working on possibly adding in support for serializable on standbys.
Are there any other ways to have serializable on standbys? Or something else?
I don't know the answer to that offhand. I mean, Oracle in a rack environment, I believe, does have it, but that's not a standby, right? That's active-active. So I don't know offhand if anybody actually has it on standbys. But their serializable isn't exactly the same as ours anyway. So that's a longer discussion. Ours is better. Let's just keep it at that. All right, one of the other things that's actually really cool in Postgres version 12 is that somebody came up with a faster way of taking a float, right, inside of a system and turning it into a text string. And this is really actually pretty impressive because it speeds up a lot of workloads where you're doing text-based transfer of the data. right? So what will happen is that it's called the Ryu, I believe is the name of the algorithm. What will happen is that when Postgres goes to convert a floating point number that's stored in binary, right, to text, we previously were using an algorithm that wasn't too unlike things like printf, if you will, right? But it wasn't nearly as efficient as this new algorithm. And so now, with this new code, it's way, way faster. And in fact, it's actually more correct in some cases. But I would caution that it means that the output may not be exactly identical to what you saw before. There is an option that you can set, which will cause it to give you the exact same results that we were doing before. If you set extra float digits, that'll actually, you can set it to a value that will give you the exact same value that we got before. But of course, then you don't get the performance improvement, right? So it's something to consider. But this is actually a really cool new algorithm that's actually very fast. And if you're doing like a copy command, if you're copying out a table that's got like 10 floats, you can see a really significant performance improvement. Yes?
This is the concept of converting floating point to text. How will it not impact the functionality of the application? Because we may have...
We do binary replication. We do physical replication, I should say. We don't do logical replication. I mean, we have logical replication as well, but...
Not the application, the application. Application things...
Oh, the application.
Because the logic, there may be some stored procedures or some views where we're using those floating point columns.
But everything stays the same internally, right? And everything's binary on the inside, right? We didn't change any of that. This is just when we go to convert it from binary to text, which we only do when we're actually about to go send it to an application or some downstream thing. All right, so this is something that I'm actually working on, and I hope to get committed in the next few days, actually, which is the ability to partially detoast or decompress a value, right? So historically, you've actually had to, if you wanted to get any part of a toasted or a compressed value, you had to decompress the whole thing into memory, right? And then even if you only wanted like the very front of it, you had to decompress the whole thing. And that is perhaps not necessarily ideal, right? In fact, there's a number of really important use cases where decompressing just the beginning will give you the answer to whether or not this particular row or this particular value is going to be useful, right? In particular, inside of PostGIS. So inside of PostGIS, you have what's called a bounding box at the beginning of the toasted data, or beginning of the data set, right? And if you have a query that's querying a whole bunch of rows, right, it's really handy to be able to just pull out the bounding box and decide based on that whether this row is valuable to you or not, right? And if you decide that it's not valuable to you, you can throw it away and not decompress the whole rest of the value, right? This is really important because GIS geometries can get very, very large, right? And you don't want to end up like decompressing the entire, coastline of Japan, right? If you can avoid it, for example, right? So if you're thinking about a case where you've got, okay, you're doing a bounding box query across, the Pacific, because that's what you want to do, and maybe you don't want to actually include Japan, but it's close enough to where your bounding box is that it's included in the index results, which can happen, right? So then you have the recheck condition, and the recheck condition is going to be able to actually pull out just the beginning of all of the rows inside of that data set and say, okay, this row, its actual bounding box, like it was part of what was considered possible in the index, but it's not actually viable, right? It doesn't actually overlap what I'm looking for, and therefore I can throw it away without having to decompress all of it, which is really, really nice. The same is true for like the beginning of text strings, right? So the beginning of text strings is another area where this is helpful, although the use case for that is somewhat less. All right, copy from with where. So this is a really handy feature. It's kind of a nice to have, if you will. We've kind of moved into the SQL features section. So you can actually have a where clause now supported by a copy from statement, which allows you to filter data coming in, which is really handy. You could already do that using file FTW, but it's a little bit awkward because then you have to create a foreign table and set that all up. Now you can do that with just copy from with a where clause, which is really nice. Create or replace aggregate. So if you ever have to deal with writing extensions that have aggregates, you may have discovered that we don't have this, and it's a big pain. Now we have it. It was actually committed to v12 like 2 days ago or something. And it's going to make writing extension scripts much easier, much simpler. And in particular, this was something that was specifically asked for by the PostGIS community, because it's going to make their lives a lot easier dealing with upgrades moving forward. Inlining of CTEs. This is another really, really big one that Postgres now has. In fact, we were often pointed out as not having inlineable CTEs as being a performance problem inside of Postgres, or at least inside of our optimizer. Because what happened is that CTEs would be treated as what's called an optimization barrier, right? And we would actually materialize the entire query inside of a CTE, right, before moving on to the next CTE or to the main query. And that's really unfortunate if maybe that main query actually threw away a lot of that data from the CTE, right? There was some kind of filter condition that just threw it away. So that was an unfortunate optimization barrier. And a lot of times people would have to rewrite their queries to pull out that CTE and put it into a subquery, right? Well, that's now gone. PG will, by default, inline the CTE if it can. There are still going to be some cases where we can't inline a CTE for various reasons, but in cases where we can, we will do so by default. We will also support the old behavior. So in the event that you actually do want that CTE to be an optimization barrier and you want us to actually materialize it, you can still do that. You just have to specify with materialized when you go to write your CTE. Any questions about that? I'm kind of surprised because people often ask questions about that one. All right, SQL JSON. So how many people work with JSON? Everybody works with JSON. A lot of people do. So we've actually made a lot of progress towards supporting the SQL JSON standard. So SQL JSON is a standard that I believe went into 2016 of SQL, and we are working to add support for it. We do not have complete support yet, but what we have done is added these various JSON path functions. So exist, match, query, query array, and query first. And then we also added a few operators, which are essentially wrappers for JSON path exists and JSON path predicate. And we're going to be adding support for those to be indexed. I think that will probably also go into 12, but I don't know for sure. I know that what we've got right now is we've got these actually committed. These were committed a couple weeks ago. And then hopefully we'll actually have index support added in for those particular operators as well that'll make working with JSON faster. And the nice thing here, of course, is that this is all going to be towards supporting the SQL standard, right? That's the point here, is to support what the SQL standard has defined. And hopefully make it easier for people to work with JSON inside of Postgres. Although I like it already. I think it's pretty good. Questions about that? Yeah.
Index support will be added for that. So it's basically like in the JSON document, you can actually point out that a particular key can be used as an index.
So what this means is that when you want to go search for a particular path inside of the JSON, right, you can, number one, you can build an index on the JSON, which will tell you, which can then be used when you issue a query, like saying, is this path in the data set? We can go use the index to find the rows where that path is actually there, right, where that JSON path is, and return back just those records. Right? We actually already have support for that, right? It's actually, but it's not in the SQL standard method, right? We have the ability already to go look for keys and look for even data values inside of JSON, inside of an index, right, using the containment operator. So that already exists, but this is supporting JSON path specifically and supporting it as SQL standard. Any questions about that? Awesome. Goodbye recovery.conf. This is a big, big change that I don't know how many people really appreciate just how big a change it is. We got rid of recovery.conf. It's not a thing anymore. It's gone. We moved all those options into the actual PostgreSQL.conf, You can also set them using alter system, right, which goes into PostgreSQL.auto.conf. It also does mean that basically every high availability solution out there is going to have to be updated to address this change because they all use recovery.conf. It really increases our flexibility quite a bit, which is great because it means that you can do things like change who the primary is on the fly. So you can actually, you'll be able to say, set the primary con info to be a different value than it was before and be able to have Postgres pick up on that change and connect to a new primary without having to restart. All right? Previously, you actually had to update the recovery.conf and then restart Postgres to get that change. And that's no longer necessary. We also have a new function called pgPromote, which will allow you to connect to a replica and say, promote yourself. And the replica will do that, right? It'll promote itself to a primary just by calling this function, which is also pretty nice. So if you're working with Postgres and you deal with high availability or even replicas, this is a big change that you're going to want to be paying attention to when you're looking at moving to version 12.
So,
yeah.
Just on that. So all the configuration options are still the same.
Yes.
So I can pretty much just go ahead and make a change in my PostgreSQL.conf, which I would carry forward from a previous upgrade. I can just say include recovery.conf and things should work fine. It should not be a
I would say that yes, it should work that well. I'm not convinced that I would necessarily go with that well. Yeah, did you have a comment about it? Oh, yeah. Yeah, you can't just include it because, yeah, you have to rename it to something else first. But if you rename it to something else and then do it as an include, I think it'll work.
Okay.
I don't think there's any reason why that wouldn't work.
Okay.
I'm not sure that I would necessarily recommend it. I'd have to think about it a little bit. But it should. One of the caveats here, though, that is something that I've been kind of pushing people to realize. If you do something like, say you do a PG-based backup, right? And you tell PG-based backup that you want to recover to a particular point in time, right? Or you set up your recovery.conf to recover to a specific point in time. If you then include that into your PostgreSQL.conf, then Postgres is going to want to recover to that specific point in time in the event that it detects that you're supposed to be doing some kind of recovery. And that's a little bit awkward in my opinion, right? Because remember, the recovery.conf didn't just have primary con info, it had things like at what point in the timeline and on what timeline do you want to recover to. And those are things that you probably don't want to have set typically. So you have to be, like if you do like a PG-based backup or something, you have some tool that writes out your recovery.conf, right, today, and it's updated to write these things into PostgreSQL.auto.conf or something. You got to be careful, right? Because you probably want to go back and remove those settings later so that you don't, when you go to use this system for something else, end up having those recovery target settings set.
And I love because I know that a lot of people, I mean me as well, and I believe a lot of other people would have a lot of emphasis on having the same set of parameters in primary and secondary and try to have as less differences as possible.
Yeah, of course.
Now there are a few parameters which I have to be very consciously setting in my primary PostgreSQL.conf. So it would be nice if I could set all of those in a separate file and just say include. On my master, maybe that file is empty or
Right.
cached
So you can do that, right? I mean, we already support including files.
Yeah. And only thing which I can think about is it could become a challenge because earlier it was very easy for me to just add a dummy recovery.conf from something trying to, if a master node went down or Postgres service got killed for some reason, I just add a recovery.conf in my data directory, and when it starts up automatically, or if a DBA starts it up accidentally, it would never become a master again because it would go and check recovery.conf and become.
Right. So there is
all those kind of procedures will happen on the code.
So there is a new file called recovery.signal,
Okay.
which is what tells Postgres now that we want it to do recovery. So you can put that file is something that you would put in,
Okay.
right, in the directory. So we do, because you're right, we still need to have something to tell us whether we're starting up as a replica or starting up as a primary. And that's that recovery.signal file. So that still is there. But everything has to be updated to use that and to build, create that file and whatnot instead of the recovery.conf file. So yeah, so big change, watch out for it. Yes?
Recovery.signal is also from version 12 onwards.
That's correct, yes. Recovery.signal is 12 and above, right? Along with this removal of recovery.conf. That's all version 12 stuff. Any other questions about that? Awesome. All right, so you're now able to control what SSL protocols are allowed. It used to be that you couldn't really control this, which was kind of annoying. You could have it enforced if you had a system where you could enable FIPS mode. In fact, that's mostly what FIPS mode did, was disable the old SSL protocols. But now you can add it into your PostgreSQL.conf to just say, don't allow these older SSL protocols, only allow TLS, whatever you want to support, which is pretty nice. And that'll have to be something that gets addressed through a lot of the kind of hardening Postgres documents that are out there, the CIS benchmark and the STIG. Covering gist indexes. So gist indexes, so B-tree indexes got support to be covering indexes. I think that was in 11. And now we've added support for gist indexes to also be able to be covering indexes. This is really handy if you want to, say, add some columns into your index to allow for an index-only scan, right? So these are columns that are not included in the actual key for the index. They're just happen to be carried alongside it so that you can pull that data out when you're querying and you have all the data available in the index to do an index-only scan, which is really, really nice. So this is one that I like. I don't know how many other people care about it, but we now have a CSV output mode for PSQL, which is kind of nice. Previously, you could get CSV out, but you had to take whatever query you were working with and shove it inside of a copy statement, right? And then it would work, but this actually allows you to get it directly. Yes?
Go back to the
yeah.
In this case, can we assume that analyze will take a little longer because when we have more columns in the index only portion?
Analyzes the heap. It doesn't actually analyze indexes. So the stats are collected for all columns when you run analyze. But it's all from the heap. We don't do any, it doesn't matter in the index. You can have whatever indexes you want or not have. You can get to a point where if you have a bazillion indexes, planning time takes longer, right? Because you've got a billion indexes for the planner to consider. But that's a different case from analyze. Analyze is not going to be any different from this.
But updates could take more time now because if I'm updating that column which is included in the index.
Of course. Yes. Yes. Correct. Of course. Yep. That's correct. I mean, that's true for any column that ends up in an index. You're increasing the load having to do with the update queries or the insert queries or the delete queries, really, to address the fact that that column is also existing in this index. So yeah, that's certainly true.
And gin indexes are kind of, so is it right to say that gin indexes are kind of a very good implementation of what gist implementations are?
Well, gist and gin are different things. Yeah, they're different things. Gin is actually an inverted index, right? And in fact, gin is interesting because you can't get index-only scans with gin, right? Because you can't build all of the data you need from the gin index in order to be able to return it to the client. That's unlike gist, right? Gist is a generalized index structure that allows extensions like PostGIS, for example, to build their own, right? So this is actually really handy for PostGIS because now you can have inside of a PostGIS geometry-based index some columns that are commonly pulled out with but are not included in your actual conditionals, right? So now you can just include those columns and get index-only scans from PostGIS queries, which is really nice. All right, CSV output mode. So this is really handy if you use PSQL a lot. You can just pset the format to be CSV, and it'll return the rows back to you in CSV format instead of in tabular format or what have you. So there's a number of other options that PSQL supports, like LaTeX as well, if you want to run a PSQL query and get LaTeX output to include inside of a slide deck like this. We've added an option to be able to sample queries. So this is a new parameter which allows you to basically say, okay, I'm going to set my logmin duration statement to be very, very low, right? Or maybe even 0. right? On a lot of systems, if you do that, you end up slowing the whole system down because you're then logging every query, and you end up having a backlog of processes trying to write into the logging system. So what we did was we added an option, log statement sample rate, that basically says, okay, we're only going to sample the queries that get, and include only a sample of those queries in our output rather than logging every query. So this is really handy for very large systems that have lots and lots of fast queries. Previously, you couldn't really get this information very easily in your logs, right? Because if you enabled logging of all slow query or all fast queries, the system would grind to a halt. So now we have this ability to have a sampling of those queries included, so you can see what those queries are and get actual values, for example, right? pgstat statements is great, but it doesn't give you actual values that are being used inside of those queries. So this is something where you can actually see actual values coming back, which is really nice. And then you can use a tool like pgbadger, which is one of my favorites, to do log analysis of this. What's that? Yes, it will log the whole statement. But it will only log a sample of the statement, right? It won't log every statement.
So how pgBudget will take the information because the complete statement is not in pgBudget will only run through the log.
No, it'll have the complete statement in it, in the log. It'll just only have a sampling of them, right? So you can see it. You mean, when you're looking at the pgbadger results, you have to realize that it's only a sample of the queries and not all of them.
Queries basically it will log maybe 10 or
Right, exactly, right. If you have 100 or...
the statement, the one log statement will be complete.
Yes, each one will be individually complete, but it'll only be every 10th or every 100th or whatever statement.
And this can be, we can modify this if you want to log each statement.
Yeah, you can change this to log every statement if you want. Yes?
How does the sampling work? Is the fraction a uniform?
Yeah, it's fractional.
Yeah. So it doesn't necessarily help you with the back pressure problem of the logging system. Like if your logging system is running on sleeves because you're logging too much, you need to tweak the sampling.
You would tweak the sample rate down, right? Yeah, exactly. So that it's logging less. I mean, you can still potentially have back pressure from the logging system if this sample rate is set too high, right? So you may need to set it lower in that case. Yeah, I mean, that is true. Yes?
Actually reads from the WAL files in the back, or does it from
No. This is not read from the wall files. So it works, every back-end process will basically check to see if, it'll essentially do a random calculation to see whether or not it should log this query, right?
It's more of a server log, not write.
Yeah, it's a server log. Yeah, it all goes into the server log, just to be clear. Sorry. This goes into the server log, just like logmin duration statement goes into the server log.
That's right, but how does it work in the background? I mean, how does it pick up all those SQL statements and
Each backend is getting the queries, right? And then it does a random calculation and says, okay, should I log this query or not based on whether or not the random value that it got back is above the threshold, right? And if it is above the threshold, then we log it. If it isn't above the threshold, then we don't, right? And that's how we can skip the actual logging expense in those cases where it's actually, so we don't have that logging expense for every query, is the point. Other queries about that? All right. So we now have a new HBA option called client cert equals verify full. So if you've been working with Postgres and you've been doing verify full for your client-side certificates, that's great, right? But that's, some people would consider that to be one-factor authentication where you're just verifying the certificate, right? Because you're doing, say, cert-based auth. We now, with this option, allow you a way to do two-factor authentication where one of the factors is a certificate and the other one might be a password, right? Or could be something else, right? It doesn't necessarily have to be a password. It could be PAM, it could be LDAP, it could be potentially Kerberos. I'm not 100% sure, but you might be able to do this with Kerberos too. But basically this gives you this ability to say, okay, every one of my users has to have a client-side certificate, and that client-side certificate must be validated by the server on connection. And then not only that, they also have to provide a password. Right? Does that make sense? So that's what you can do with this new option, which is pretty handy.
So it is not a combination, it's not a two-factor authentication, just two-factor authentication, but it is actually adding the second factor to the SSL connection.
It's like adding a second factor to SSL. So, I mean, it used to be that Postgres supported SSL connections with client-side certificates, right? And you could use that certificate to authenticate, right? Or you could use the certificate to just perform the connection between the two, but the certificate wasn't actually validated, right? Server-side, it was just used essentially for encryption. This does both, right? And allows you to use it with other authentication methods in combination so that you can require a password as well, for example. Or potentially something else, but the password case is the one that most people are thinking about. Yes?
Is there a plan to add feature to encrypt even the queries which are coming in from the clients? I have heard of
So SSL is encrypted.
but it only encrypts the data which is sent from the server to the client.
No, it's encrypted in both directions, I promise you.
Okay.
Absolutely. It's, yeah, when you have an SSL-based encryption, or SSL-based connection, it's encrypted in both ways.
Okay.
Yeah.
What will be log and log?
What will be?
The statement, will it be encrypted in the logs?
No, the statement in the log is not encrypted. No. Yeah. Postgres is, when a query gets sent from the client to the server, the client will, through OpenSSL, encrypt the data, right, send it across the wire, and then the backend will immediately decrypt it, and then process it as if it was an unencrypted request, right?
It's just the connection which is encrypted.
It's just the connection, that's right.
But the data itself on the server side, or like logs or something else, they are not really encrypted.
Yeah, everything on the server is still going to be unencrypted, I mean, unless you're using like pgCrypto or something, right? So pgCrypto is a way that you can have data server-side encrypted, or you can just encrypt it client-side and send it over, right, as well. But this is, what I'm talking about here is all just connection-based encryption. Any other questions about that? Any other questions at all? Because that's what I had. And I've got a few minutes here left. I love all the questions that people have been having. It's been great. So I think I have a couple minutes left for questions.